Welcome to another session of Foundations of Microsoft Azure Stack. My name is Mark Grimes and I'll be presenting this module on Azure Stack Security. I've made two shortcuts for you for the content to review afterwards, aka.ms/Azure Stack/security and aka.ms/Azure Stack/compliance. There's a lot of great information there you want to be sure to review at a later point. The purpose of this module is to highlight and discuss the investments in security and compliance of the Azure Stack solution. There is a lot of leveraged investment from Windows Server 2019, so please reference and investigate the server features where applicable. Security considerations and compliance regulations are among the main drivers for using hybrid clouds. Azure Stack is designed for these scenarios. Two security postures coexist in Azure Stack. The first layer is the Azure Stack infrastructure, which includes the hardware components up to the Azure Resource Manager. The first layer includes the administrator and the tenant portals. The second layer consists of the workloads created, deployed, and managed by tenants. The second layer also includes items like virtual machines and app services websites. Let's start with infrastructure security. When we look at traditional approaches to security, it's almost like a castle with a moat around the walls to secure it. Cybersecurity used to mean building a bigger moat and a bigger wall. In the IT world, this translates to large firewalls, expensive devices that have been complex to manage and configure. However, over time, vulnerabilities and attackers have evolved and are much more advanced and sophisticated than they were previously. So what we want to do and have done with Azure Stack is leverage learnings from public cloud security. While some of the traditional approaches were good and are somewhat still relevant, the move to the cloud-based world, anywhere access, strong firewalls are just not good enough anymore. Security must focus on identity, infrastructure, and the application pillars holistically, as well as network access and controls to fully secure the environment. Today's reality is that fundamentally, if somebody wants to get in, they're getting in and accept that. That was a quote from Michael Hayden, the former director of the NSA and CIA. What we tell clients is that, number one, you're in the fight whether you thought you were or not. And number two, you're almost certainly are penetrated. The guiding principle of Microsoft's security strategy is to assume breach. The Microsoft Global Incident Response Team works around the clock to mitigate the effects of any attack against our cloud services. And therefore, security is built into our Microsoft business products and cloud services from the ground up. Starting with the security development lifecycle, which is a mandatory development process that embeds security requirements into every phase of the development process. You can learn more about SDL or the security development lifecycle at the Microsoft Trust Center at aka.ms/Azure/trust. Our vision for Azure Stack with security is to provide our customers with a similar level of security and protection to Azure while running with Azure Stack in hostile environments. And what we mean by hostile environments is it gets back to the assumed breach. A lot of customers, the statistics have shown that they don't even know that they've been breached for up to 200 days. So as long as there is a network access point or there are people working inside the organization that can use social engineering, it is a hostile environment whenever we're in a connected and even in a disconnected scenario where we have possible rogue admins. So we want to make sure that we lock this down. At one of the recent conventions, I had the pleasure of speaking with Jeffrey Snover, who talked about his dream of what he wanted to do back when he started in the Windows NT server environment. And he said back in those days, we didn't know what kind of hardware, what kind of OEM was used, what kind of drivers. And therefore, at Microsoft, we didn't have the ability to lock down and secure all these multiple different options and configurations and vendors in the way that we now can do with Azure Stack. Since we partner with and we test and we validate with very specific vendors and very specific configurations, therefore, we can lock everything down in the way that we find that will best serve our customers. This slide, if you've seen any presentations at Microsoft Ignite or on YouTube or in Channel 9, this is a very standard picture we show of the upper half of the picture being the user workloads in the tenant space, and the bottom half being what we call below the waterline or under the hood of the car, the Azure Stack infrastructure. The point is on this is that you don't need to know and understand in depth the internals, because internals are internals. They're locked. It's a black box. It's sealed. The only time that will ever be open and available is on a support call where any other type of Azure Stack operator intervention is not possible to fix things. Then through a support call, through a two-way exchange, which we'll discuss in another video, we can unlock that environment, and then the support team can guide the Azure Stack operator. But knowing the depths and controlling and trying to manipulate that just doesn't need to be known, because from a security perspective, we make it as secure as possible, and that's what we're going to talk about in this session. So the security posture defined by Microsoft is A, we are hardened by default, and B, we assume breach, as we talked about. From the Azure Stack operator's responsibility, it's more about management. They are operating the system. They are not designing, they are not, tweaking the internals, because again, that's a black box. The user's responsibility, which is very important depending on what role you play as an administrator. So if you think about a cloud solution provider that has customers that run in those operator space, they are responsible for the security posture and management of those subscriptions, just as customers are likewise in Azure. In Azure, Microsoft plays the Azure Stack operator. We build and configure all the resource providers to provide the necessary functions that are needed for our customers. But inside everyone's own user subscription in Azure, I tell, as a consultant, my customers the same story, that they have the responsibility to strengthen that security posture within those subscriptions which they control, just as users and tenants do in Azure Stack. It's a very similar story. So the idea here is when you get an Azure Stack appliance, the internals are production ready. Most everything else is production ready, other than the capabilities that you as the Azure Stack operator would add to it, and then make additional controls or guardrails for those services or those roles. Versus when you build a Windows Server, as an example, a Windows Server has some features that lock it down, but there are not STIG policies applied to it or templates, and we don't have to go through hundreds or thousands of steps to lock it down and secure it. We are hardened by default, and we do this for the best interest of our customers. So hardware-rooted trust. There are three things we want to talk about that from the hardware perspective make this a more secure environment. So the key point here is we are secure by default. It's built in rather than bolted on, which you would have to do with a traditional server environment or even a virtualized environment. Let's start with UEFI, or also known as UFI. UFI is a replacement for the older BIOS firmware interface and the EFI, or extensible firmware interface, 1.10 specifications. UFI provides all the security benefits that Azure Stack leverages by default and by design, such as Secure Boot, Windows Defender Device Guard, Windows Defender Credential Guard, and Windows Defender Exploit Guard. All of these things require UFI firmware, so that's why we start with that. Secure Boot is a security standard developed by members of the PC industry to help make sure that the device boots using only software that is trusted by the original equipment manufacturer, or OEM. When the PC starts, the firmware checks the signature of each piece of boot software, including the UEFI firmware drivers, EFI applications, and the operating system. If the signatures are valid, the PC boots, and the firmware gives control to the operating system. TPM 2.0, which is the Trusted Platform Module. This is a technology that's designed to provide hardware-based security-related functions. A TPM chip is essentially a secure crypto processor that helps you with actions such as generating, storing, and limiting the use of cryptographic keys. These are the ways that we provide a hardware root of trust. Software attack surface reduction. Azure Stack, as we said, makes use of the latest Windows Server security features. One of them is also known as Windows Defender Device Guard, which provides application whitelisting and ensures that only authorized code runs within the Azure Stack infrastructure. Authorized code is signed by either Microsoft or the OEM partner. The signed authorized code is included in the list of allowed software specified in a policy defined by Microsoft. In other words, only software that has been approved to run in the Azure Stack infrastructure can be executed. Any attempt to execute unauthorized code is blocked, and an audit will be generated. The Device Guard also prevents third-party agents or software from running in the Azure Stack infrastructure. Another Windows Server security feature in Azure Stack is Windows Defender Credential Guard, which is used to protect Azure Stack infrastructure credentials from pass-the-hash and pass-the-ticket attacks. Every component in Azure Stack, both Hyper-V hosts and virtual machines, are protected with Windows Defender antivirus. In connected scenarios, antivirus definition and engine updates are applied multiple times a day, and even in disconnected scenarios, anti-malware updates are applied as part of the monthly Azure Stack updates. And finally, as noted in here, we'll talk more about the network portion, but we also disable legacy protocols, for example, SMB v1 and SSL. The Azure Stack infrastructure components communicate using channels encrypted with TLS 1.2. Encryption certificates are self-managed by the infrastructure. All external infrastructure endpoints, such as the REST endpoints or the Azure Stack portal, support TLS 1.2 for secure communications. Encryption certificates, either from a third party or your enterprise certificate authority, must be provided for those endpoints. While self-signed certificates can be used for these external endpoints, Microsoft strongly advises against using them. Azure Stack infrastructure comes with multiple layers of network access control, ACLs. The ACLs prevent unauthorized access to the infrastructure components and limit infrastructure communications to only the paths that are required for its functioning. Network ACLs are enforced in 3 different layers. First, top-of-the-rack switches. Second, SDN, or software-defined networks. And third, host and VM operating system firewalls. Azure Stack uses various secrets to maintain secure communication between the Azure Stack infrastructure resources and services. From internal secrets, all the certificates, passwords, secure strings, and keys used by the Azure Stack infrastructure happen without intervention of the Azure Stack operator. For external secrets, there are infrastructure server certificates for external facing services that are provided by the Azure Stack operator. Some of these include certificates for the following services, such as the Administrator Portal, the Public Portal, Administrator Azure Resource Manager, Key Vault, Admin Extension Host, ACS, and in scenarios where we have ADFS involved, ADFS and the graph. Assume breach. We said this is a common theme at Microsoft. So the security posture for Azure Stack is designed to defend against modern threats and was built to meet the requirements from the major compliance standards. As a result, the security posture of the Azure Stack infrastructure is built on these two pillars. First, assuming breach. We start with the assumption that the system has already been breached, and we focus on detecting and limiting the impact of breaches versus only trying to prevent attacks. We've also mentioned it's hardened by default. Since the infrastructure runs on well-defined hardware and software, Azure Stack enables, configures, and validates all the security features by default. Because Azure Stack is delivered as an integrated system, the security posture of the Azure Stack infrastructure is defined by Microsoft. Just like in Azure, tenants are responsible for defining the security posture of their tenant workloads. Administration in Azure Stack is controlled through 3 entry points, each with a very specific purpose. First, the administrator portal provides a point-and-click experience for daily management operations. Second, Azure Resource Manager, or ARM, exposes all the management operations of the administrator portal via a REST API, which is also used by PowerShell and Azure CLI or command line interface. And third, for specific low-level operations, for example, data center integration or support scenarios, Azure Stack exposes a PowerShell endpoint called the Privileged Endpoint, also known as the PEP or PEP. This endpoint exposes only a whitelisted set of commandlets and is heavily audited. As I mentioned earlier, this will be detailed in another workshop later. Our security best practices are, as we mentioned, we follow the secure development lifecycle, threat modeling of each component. We've performed third-party penetration testing, automatic patching and updating of the entire infrastructure, and we have rotation of secrets. Passwords and secrets are updated on a regular basis, and you can read more about the updates at aka.ms/azurestack/updates. One note about the updates is that the core patch and update cycles are totally automatic and transparent to the customer within the system. Once a patch is released, the customer has the option as to when to deploy the patch for the Azure Stack updates. The updates must be applied to the core infrastructure within a certain period to be supported. As an example, that is usually an N-2 cycle. So if you were at version 1908, you could be back to 1907, 1906. So 2 versions back, you could still be in supportability. But if you went back a 3rd version, you would fall out of support. And before the support process would begin, you would need to get up to at least N-2. But of course, from a security perspective, it's always best to be at the highest level possible so that we make sure that we've averted any potential security risks. Infrastructure security. Now we're going to talk about benefits of the closed system. With thousands of new malicious files created every day using traditional methods like antivirus solutions, signature-based detection to fight against malware provides an inadequate defense against new attacks. In most organizations, information is the most valuable asset, and ensuring that only approved users have access to that information is imperative. However, when a user runs a process, that process has the same level access to data that the user has. As a result, sensitive information could easily be deleted or transmitted out of the organization if a user knowingly or unknowingly runs malicious software. Application control is a crucial line of defense for protecting enterprises given today's threat landscape, and it has an inherent advantage over traditional antivirus solutions. Specifically, application control moves away from the traditional application trust model, where all applications are assumed trustworthy by default, to one where applications must earn trust in order to run. Windows Defender Application Control, WDAC, which was formerly known as Device Guard, can help mitigate these types of security threats by restricting the applications that users are allowed to run and the code that runs in the system core or kernel. WDAC, again formerly known as Device Guard, policies also block unsigned scripts and MSIs, and Windows PowerShell will run in constrained language mode. Azure Stack makes use of Windows Server Software-Defined Networking Technologies, or SDN. Some of the following features allow us to implement between the security at the fabric and the host level. Within SDN, some of the key features are it will create thousands of logical network segments. And again, this is very similar to the way it works in public Azure. It will use user-defined routing, or UDR, for virtual appliances to restrict the pathways where communication occurs. There's multi-tenancy support through individual routing domains to separate the environments. It leverages VXLAN and NVGRE encapsulation to protect the packets. There's distributed router on each Hyper-V host, integration with a software load balancer, SLB, gateways, QoS, and distributed firewall, and network virtualization policies programmed through the Microsoft controller using OVSDB. JIA, or Just Enough Access, overcomes many of the challenges of implementing a comprehensive RBAC model, also known as role-based access control. Users can perform only those tasks for which they are authorized as part of their role by using Windows PowerShell constrained run spaces. Users can perform required tasks without being given administrator rights on the servers. The tasks that users are allowed to perform and their server access are defined and managed from a central configuration server by using Windows PowerShell Desired State Configuration, also known as DSC. There's constant and detailed logging, which will give details about who has accessed the environment and what has been changed. One of our goals is to reduce the number of administrators in the environment. So JIA, or Just Enough Access, enables administration and management of computers without the need for privileged credentials. We want to limit what users can do with control. So we decide precisely what actions you'll let your users carry out, for instance, which commandlets, functions, and external commands that can be run. JIA eliminates the need for elevated privileged administrator credentials that can be lost, stolen, or misused. We want to see what users are doing with actionable logging and reporting. All operations performed through the JIA endpoint can be recorded in the Windows event log. These event logs show who accessed the environment and when, and what changes were made. Fourth section of infrastructure security in a closed system. So we look at known system behavior, what are known correct behaviors, known potentially suspected behaviors, and known who accesses what. And from a security perspective, the advantages are that we can aggregate events and auditing and provide customized configurations. So the end result in Azure Stack is you see what you need to know and when you need to know it. And we limit the amount of noise that would otherwise happen in a typical event viewer with thousands and thousands of red lights and green lights. But in Azure Stack, it's the things that you need to know most that will be surfaced in the portal for you. Next, let's talk about Azure Stack compliance a little bit more in depth than what we've done to protect it for you. The major standards of compliance for Azure Stack are PCI, FedRAMP, HIPAA, CSA, CCM, ISO 27001 and 2. Only validated are in Azure Stack, we are only validated for the technology component, which is what happens. The people and process components of the certification are still the customer's responsibilities. And again, this is, scratch that. Documentation for compliance standards. Again, we are assessed, not certified, because we can control the software and hardware, but not the peoples and processes. So if you want to get more details about these standards, you can download them at aka.ms/Azure Stack Compliance. Recently, we received FedRAMP High assessment. Knowing that preparing compliance paperwork is a very tedious task, we pre-compiled the documentation for our customers. Since Azure Stack is delivered as an integrated system through hardware partners, we are in a unique position to perform a formal compliance assessment of Azure Stack that applies to all our customers. This resulted in a set of pre-compiled compliance documents that customers can now use to accelerate their compliance certification process. So we're happy to announce that Coalfire, a qualified security assessor or QSA, and an independent auditing firm, has audited and evaluated Azure Stack infrastructure against the technical controls of PCI DSS and the CSA Cloud Control Matrix, and found that Azure Stack satisfies the applicable controls. In the assessor's own words, they said, "It is Coalfire's opinion that Microsoft Azure Stack Integrated System, reviewed between July 27th and October 27th, can be effective in creating a PCI DSS compliant infrastructure and to assist in a comprehensive program of compliance with PCI DSS version 3.2. Furthermore, it is Coalfire's opinion that Microsoft Azure Stack, as deployed in the original equipment manufacturer OEM integrated system test, which was reviewed between July 27th and October 27th, 2017, can be effective in creating a CSA CCM 3.0.1 compliant infrastructure and can assist in a comprehensive program of compliance with CSA CCM version 3.0.1. So we understand that compliance encompasses not only the Azure Stack infrastructure, but also the workloads that are deployed on it. To reduce the complexity of compliance related to workloads, Azure Stack and the Azure Blueprint program are coming together to deliver turnkey compliance solutions to support our customers' compliance needs and help them rapidly deliver value to their companies and customers. We will share more details on the Azure Blueprint program for Azure Stack in the coming months, so stay tuned. Auditing and intrusion detection. So when we look at the FedRAMP Control ID SI4 and NIST standard 853v4, this is the information system discovers, collects, distributes, and uses indicators of compromise. So in Microsoft Azure Stack, the implementation description is that all activity on Azure Stack is logged, and logs can be collected through integration with a Security Information and Event Management or SIEM tool with the syslog client of Azure Stack. When Azure Stack is deployed with a deployment worksheet, you can actually pre-configure this by putting the address of the SIEM server to help expedite that process. All this communication happens across TLS 1.2 and can leverage UDP and TCP depending on the configuration settings that you put. Ideally, we want to use mutual authentication for the most secure aspect of this. Recently also, Splunk has just come out with some add-ons, and there is a Splunk add-on and a Splunk app. So here's the difference. The Microsoft Azure Stack app for Splunk provides dashboards and visualizations for data gathered via the Azure Stack add-on for Splunk. The Microsoft Azure Stack add-on provides parsing rules for the Azure Stack syslog data. So you use that together with the app for Splunk to gain insight into your Azure Stack environment. Note that these are not in the Azure Stack Marketplace, but you can download these in the links provided below at the Splunk base. Let's take a look at the integration architecture of on a high level for SIEM integration. So on the Microsoft side, inside of Azure Stack, we have a syslog client that can communicate with the syslog server, and it can pull in information from the infrastructure VMs, the server OSs. And then from the hardware side of the equation inside of Azure Stack, there are hardware specific bits of information that could be fed through the SIEM system from the switches, the TORs, the BMC, the hardware partner VMs, and the hardware lifecycle hosts, or HLH. On the other side of the coin, in the user workloads, there are two options for gathering this information. In the user workloads, you could install an agent or collector from your favorite SIEM solution, and then that could send information into the external SIEM. Or option two, you can leverage solutions that may exist or may be coming in the future in the Azure Stack marketplace. And again, we'll talk more about the marketplace later on in another module, but the Azure Stack operator would have to install and make those available in the marketplace for all the user subscriptions. So once that's made available in the marketplace, inside the user subscription, those would just appear. So just before this presentation, I went to check to see what currently existed out there, and we do have one solution in there right now, which is called Event Tracker SIEM. And again, if the Azure Stack operator downloads this and puts it in the marketplace, users would then see Event Tracker SIEM. And this is pretty interesting. So here's an overview of Event Tracker SIEM. It's known as a comprehensive security platform that delivers advanced security tools with audit-ready compliance capabilities. It offers a wide range of security essentials from endpoint threat detection to behavioral correlation. Detection deficits occur from a lack of resources or awareness in the network. Event Tracker SIEM collates millions of security and log events and provides actionable results in dynamic dashboards so you can pinpoint indicators of a compromise while maintaining archives to meet regulatory retention requirements. Event Tracker improves the efficiency and productivity of the IT staff by prioritizing operational incidents, and with real-time alerting enables them to address the most critical incidents first. So in order to check that out, there's a link at aka.ms/Azure/Stack/Event Tracker for that specific one. And to see at any time what current things exist in the marketplace, at the top of the slide, you can go to aka.ms/Azure/Stack/Marketplace to see all the things possible that an Azure Stack operator can enable for the users. So in approaching security for Azure Stack, we need to know what we need to focus on versus what we do not need to focus on. As we said earlier, internals are internal, so that covers most of those things. But we want to focus on workload protection and controls. As we said, in the user space, the customer is responsible. So depending on the type of agreement you have, whether your customers are internal or external to your organization, will determine what type of controls you as the provider or Azure Stack operator has. In some cases, you may just enable the subscriptions and then they take over and then they have full responsibility. But I've seen other scenarios where the provider or service provider has an agreement that they will do the protection. And in that case, they need to have the appropriate rights in those user subscriptions, because when you make an offer plan and quota, which we'll talk about later in another session, and allow a user or a tenant to create a new subscription, if they have that initial access, you have no access to it at all unless they grant you rights into that subscription. So what another approach I've seen some organizations do is they will actually create the subscriptions. They will take ownership of that initially, build it, put in the controls and protection, and then add the users for that organization in that subscription. And then those users will then remove the initial provider once everything has been built. So that's different approaches to focusing on the control on the user space. Likewise, for defining role-based access control models for admin. So in the scenario I just described, that depends on do you as the provider take control and then grant someone else, or do you let them take over and then they grant you limited access, such as maybe read access, so that you can look inside their subscriptions and see what's going on. In another presentation, we talked a little bit more about role-based access control, but essentially you have three various rights, owner, contributor, and reader. And reader is a good example of if your customer wants or needs your help or needs monitoring tools that you own and control, reader rights are very appropriate for that. I also tell people that have cloud organizations and they have cloud-based architects that a reader RBAC role is a good one because they can do no harm, but they can go in and look at it. Likewise, I as a consultant, when I go into projects, whether it's an Azure or Azure Stack, I ask for read-only access, again, because I can do no harm, but provided they allow me to look and see at things, I can then scan entirely across it, their subscription. Virtual network security. So in the Azure Stack operator side, there's generally not a lot that you have to do for this. The only thing that comes to mind for me is there'll be a workshop that will talk more about app services and some specific configuration you have to do in your NSGs or network security groups to allow app services to function properly, and that's primarily in the use case scenario where you might have a file server off the stack or in a different network, and you have to allow that access to that. But generally, in most cases, in the operator side, there's not much else you have to do because you're really focused on providing resource providers for things like virtual machines, templates, and for app services and other templates that you might find, as the example we talked about in the syslog Splunk solution for that, although that one's not in the marketplace, but the event tracker is. However, for network security in the user space, again, this is an area that I think is pretty important to have a discussion with your customers, again, whether they're internal to your organization or external to the organization. And you can either let them and hopefully trust them to do this right. So as an example, as an Azure Stack operator, if I provide the things they need based on their requirements in the marketplace, and I provide the resource providers based on their requirements for their applications, I create an offer plan and quota, and then they subscribe and make a subscription or two or three. They have everything they need, but then do we want them to build their own networks and configure the network security properly? Again, that's a trust. Do you know that they have the skills and the capabilities, or do they not? And if they don't, do they want you to do that? So if they want you to do that, you have two ways to do it. You can do it the easy way, or you can do it the hard way. The hard way would be that every time they raise their hand and they go, we need some control, some help, they would have to grant you access, and you would need more than read access, maybe read access initially to look into their subscription and see what they've configured properly or not. But then you would have to have contributor rights to actually configure these things. And then they'll call you again, and then they'll call you again, and then they'll call you again. So that's the harder way to do it. The preferred approach is to define patterns. So for their applications and their workloads, you would create templates. So instead of just putting these things in the marketplace, you can make custom templates, and we'll talk about that in another workshop, where you can have everything pre-built. So for example, they're going to have a 3-tiered application with front end, middle tier, back end. And we're going to have a UDR that points to a network virtual appliance to provide egress throughout the correct pathway. And it will have network security groups between those layers, and the ports and protocols are defined. And we could actually define that in a template to provide that network security, publish that in the marketplace. And then when the user in that tenant space goes to get that application, they literally can see an icon in their marketplace, which you had created and provided as an Azure Stack operator. They literally click to deploy, and everything is built magically. And if you didn't do that and you hadn't done that, they would literally just grab a VM. Maybe the VM has the apps in it, But they would still have to make the networks. They'd have to make the subnets. They'd have to make the UDRs. They'd have to make the NSGs. And again, you're back to the hard method and the support calls and the can you please can help us again and again and again. My recommendation is to build these into the templates, build it as a complete solution based on the requirements. And then you're doing them a service because it makes it super simple for them to deploy. And also reduce your calls for again and again and again support. Focus on process and procedure refinements. So that's an example of a process, that we just mentioned, that you're creating solution templates for that. And also whether they want you in their subscription or not, from a role-based access control, defining who has what rights. As we mentioned in another workshop, there are not built-in groups like, for example, in Azure, we'll have a virtual machine contributor or a network contributor. There aren't built-in roles that way. The only built-in roles we have across Azure Stack are owner, contributor, reader, and they're not per specific function. But if we want to delegate those out and you have a larger organization and maybe have multiple Azure Stack operators on the operator side, or you have multiple admins within the user tenant space, then you define who has what rights, and you can actually then make custom RBAC roles for those rights to do things. So finally, as we mentioned, do not focus on below the stack, things like performing platform hardening or agent-based security solutions on Azure Stack nodes, deep analysis of settings and configurations, controls that require physical access, because internals are internals and you do not need to worry about those. Security is a never-ending journey. So every update, there's a release for security updates, and we'll talk a little bit more about TLS and how you can configure that. But Azure Stack architecture overall is built on two security principal pillars, as we mentioned: assume breach, hardened by default, and therefore continual updates will be made whenever it makes sense to improve the overall security posture of the original and even the updated designs. So a little more information about TLS. Azure Stack infrastructure uses exclusively TLS 1.2, as we mentioned. For the external interfaces, Azure Stack defaults to TLS 1.2. However, for backward compatibility, it also supports negotiating down to TLS 1.1 and 1.0 in case your requirements still need that. When a TLS client requests to communicate over TLS 1.1 or 1.0 even, Azure Stack honors the request by negotiating to lower TLS version. But if the client requests TLS 1.2, Azure Stack will establish a TLS connection using TLS 1.2. But since TLS 1.0 and 1.1 are incrementally being deprecated, and in some cases even banned by organizations and compliance standards, beginning with the Azure Stack 1906 update, you can now configure the TLS policy in Azure Stack. You can enforce a TLS 1.2 only policy where any attempt of establishing a TLS session with a version lower than 1.2 is not permitted and rejected. Note, Microsoft recommends using TLS 1.2 only for Azure Stack production environments, and that's for your protection. If you want to look more about the settings specific to TLS, note on the slide aka.ms/azurestack/TLS, and on any kind of future updates on the progress of where we're at, what was recently released, or what we're working on, at the bottom, you can go to aka.ms/azurestack/roadmap. In summary, as we've said throughout the presentation, Azure Stack is hardened by design. Internals are internals. The rest you worry about in the Azure Stack operator space. In the user space, it is their responsibility unless you have an agreement or an SLA that it's your responsibility. Then you have to work with your user based on the requirements to define the guardrails and controls that are necessary for their applications and their workloads. Always think about cloud-enabled security versus traditional. This is a conversation I have often both in Azure and Azure Stack, because the mentality is still the castle and the moat. And while that's still important and valid, they need to look at what we say at Microsoft, that identity is the new security boundary. That is where we need to focus and control and limit the access. We have a lockdown infrastructure. We have simplified auditing. We have a well-defined patch and update process. Make sure you read that documentation on that. That concludes our session on Azure Security. I hope it was useful and the links provided will help you out. Thank you very much. This is Mark from Microsoft. Goodbye.